Hello everyone. Today we're going to be continuing our discussion of completing the square and showing how to use that to find the minimum or maximum value of a parabola, which really involves converting a parabolic equation y equals ax squared plus bx plus c from standard form into vertex form, which is y equals a times x minus h squared plus k. So in the textbook, it's going to ask you a lot of questions about finding the minimum or maximum, which involves finding the vertex form. But when I ask you questions on the test, I'm going to be specifically asking you for the vertex form and not the minimum or maximum. So we're going to be working on how to find the minimum or maximum, but just know that if you see a question on my test that says, what is this equation in vertex form, it's the same thing, but you don't have to find the minimum or maximum as well. So first we're going to start off with y is equal to negative x squared plus 2x plus 7. And we want to find the minimum or maximum. Well, first, how do we know if this parabola has a minimum or a maximum? Well, parabolas are either going to open up or they're going to open down. This parabola has a negative sign here, which means it's going to open down, and thus it has a maximum. Great. So how do we find this maximum? Well, what we're going to do is we're going to use our completing the square technique to transform this equation into vertex form. So the first step is I'm going to subtract 7 from both sides. This will just make it a little bit easier for me to see what's going on. So then we have y minus 7 is equal to x squared plus 2x. And now here we have a term that's x squared and a term that has just an x in it, and we don't have a term that does not have an x in it, which means we're pretty ready to go for completing the square. So we're going to complete the square here, and this is negative. So what I'm going to do is I'm going to factor out the negative. So we're going to have y minus 7 is equal to negative x squared minus 2x. Okay, and the reason I did that was it's kind of difficult to conceptualize completing the square when you have a negative. It's still possible, but just to make it a little bit easier on ourselves. So this is going to be x squared, and then this part here is going to have a side length of negative 2. So this area will be negative 2x, and we're going to split it down the middle to get an area of x squared here, and we'll have 1 here, which is negative 1, so this area is negative x, and this area is also negative x, and the missing area, since these side lengths are 1, it'll be negative 1 times negative 1, so this missing area will be 1. So what that means is that I'm going to want to add 1 to both sides. So we're going to have y minus 7 plus 1, but then I'm going to choose to add the 1 inside the parentheses. However, since we factored out the negative, we would have to subtract 1. The reason for this is if I said plus 1 here, and I wanted to put the 1 inside the parentheses, well, I'd have to factor out the negative in order to put it inside the parentheses again. So we're just going to leave it like that. Now we know that this square represents this equation, so we know that this is going to be y minus 7, negative 7 plus 6 is y minus 6, is equal to negative x minus 1 squared, just based on our square diagram, and we will get, by add 6 to both sides, y equals negative x minus 1 squared plus 6. So this equation is in vertex form, and this tells me the vertex is 1, 6. Just using our knowledge from vertex form, which is y equals a times x minus h squared plus k. So since this parabola has a maximum, our maximum value is 6. So the maximum value is 6. But on the test, I'm going to be asking you for the equation in vertex form, so this would be our final answer. But just so you get practiced using big ideas, that's what the question is going to be asking. Now for our second one, we're going to be doing y is equal to x squared plus 12x plus 40, and we want to find the minimum or the maximum value. So first of all, does this have a minimum or a maximum? Well, if it opens up, it has a minimum, and if it opens down, it has a maximum. Since the coefficient of x squared is positive, we know it's going to open up, so that means we know there is a minimum. So my first step is I'm going to be moving this 40 to the other side of the equation by subtracting 40 from both sides, just to make it a little bit easier to work with here, because that's the core, which is going to make up the part that I complete the square for. So we'll have y minus 40 equals x squared plus 12x. Now we want to complete the square here. So we'll have our area for x squared is going to be in red. So the area here is x squared. And then there's an x here that I needed to write. And now this side length is going to be 12. So this area is 12x. So this rectangle represents the area of our right side of the equation. So I'm going to split this in half to get x, and then x squared. So this side length now is going to be 6 long. So our area is 6x, and I know that doesn't exactly, it's a little bit longer honestly than the 12, but just imagine in your mind that it is half the length. Yeah, 6x here. So then this missing area in blue, well, this side length is 6 and this side length is 6, so here must be 36. So what I'm going to do is I'm going to add 36 to both sides. Remember, I'm trying to keep the equation balanced, so I have to do the same thing to both sides. Now, I don't have to worry about the sign flipping at all on this side because I haven't had to factor out a negative. Okay, so negative 40 plus 36 is y minus 4, which is equal to x squared plus 12x plus 36. All right, now this square, which represents this, the area is x squared plus 12x plus 36, which is perfectly represented here. And since this square has side lengths x plus 6 and x plus 6, this area of a square is just the two sides multiplied together. So if this is the area, then logically we can conclude that this factors into x plus 6 squared. You could factor it by hand if you'd like to verify, and that's totally fine. So then we're going to add 4 to both sides to get y is equal to x plus 6 squared plus 4, which tells me the vertex is negative 6, 4, based on vertex form, which this is now in vertex form, so that would be our final answer if I were asking the problem on the test, but for the purposes of big ideas, we would have this, and our y value is 4, so 4 is the minimum value. And it's not going to be the x value because x values go infinitely long left and right, so you couldn't have a minimum or maximum. Now we're going to do one final problem, which is y is equal to negative x squared minus 4x plus 4. So what I'm going to do first, I'm trying to find the minimum and the maximum. First, we're going to recognize that there's going to be a maximum because this parabola, since it's negative, is going to open down, which means it must have a negative. Now what we're going to do is we are going to subtract 4 from both sides, just kind of like to say 4, we're going to deal with you later. We're going to just store you on the left side of the equation so I can focus on the part that we want to complete the square for. So we're trying to complete the square for this portion. We're going to put red for x squared and green for negative 4x. Sorry, this is negative x squared. So because this value is negative, we need to factor out the negative. So we're going to have, factoring this out, we'll have negative x squared plus 4x. Now, just to make sure that it's clear what we're doing, this is really negative 1 times x squared plus 4x. So if you FOILed in negative 1, you would get negative x squared minus 4x. So that's why we're allowed to factor out a minus sign. Okay, so now we're going to complete the square here. So the area of this portion of the square is x squared. And then this side length is going to be 4. So the area here is 4x. Now we're going to split it in half. And we're going to go over to this side length is x, and here is x, and here's x squared. And then we're going to keep 1/2 on the same side. So this is 2 now. This is 2x. Then we have another side of 2x. And then the missing quadrant is going to have a side length of 2 and 2, so its area is 4. So that means we know we're going to have to add 4 to both sides, so we're going to say plus 4. And then I want to make sure to do it in the parentheses, so in order for that to have happened, I'd have to have factored out the 4. So I'm going to subtract 4 inside the parentheses to get y is equal to negative x squared plus 4x minus 4. Sorry, rather, we want to make sure to add it inside the parentheses because we want to make sure that the area that we're representing is added, is going to make the area of the part inside the parentheses equal to the square. So we're going to add 4 to the side, which means that we're going to subtract 4 from the right-hand side because we're adding 4 inside the parentheses, which means we must subtract 4 from the left-hand side with the y value. So we're going to get y equal minus 8 is equal to negative x squared plus 4x plus 4. So then we are going to say, okay, well, I know that this is going to factor based on our area model. So we'll have y minus 8 is equal to negative x plus 2 squared. And then we're going to add 8 to both sides. We get y is equal to negative x plus 2 squared plus 8, which is in vertex form. So the vertex is negative 2, 8, which means our maximum is 8. And that would be our final answer. And if I asked you for vertex form, that would be our final answer.